In this video, I will show you how to use SMKRUN to process emissions for residential wood combustion or RWC. On my training instance, I already have a SMKRUN alias that point to smkrun.py. This allowed me to initiate SMKRUN at any location. Now there is several ways to use SMKRUN and navigate to the run script for RWC. One way is just type SMKRUN directly, and it should show me the GUI interface of SMKRUN. And then I will using the root button here to navigate to the top level directory that hosts these RWC's run scripts. So I know that under home CMS training 2022 HECB6 2022M, which is again the case ID for 2022 V2 emissions modeling platform, and all of the SMKRUN scripts are under the scripts directory. So you can either go into non-point, which even though it's not shown here, but this is where the location of the RWC run script are located in, or just go back one level up and then choose. The panel on the left looks like a file browsers with the trees, the directory tree structure, and like I mentioned earlier, the run script for RWCs are under the known point directory. So to load up the run script for RWC, I double click on that, and the run script content will be populated into the variable tab and the source tab. The source tab is similar to how we viewing the content of the run script using VI editor, for example. There is also a different way to navigate to the run script for RWC from SMKRUN. That is to use the additional arguments. So I'm using SMKRUN space and then -d, which stands for directories, and I know that my run script under home CMS training 2022 and scripts, and then it's under the known point directory. So as I type that in, SMKRUN GUI interface will show up again, but now it's jumped right into that known point directory where the RWC is located in. So now again I can load up the run script contents as I did in the earlier demonstration. Other way to do this is we can directly load the run script into SMKRUN. Now instead of using -d, I use a -f. F stands for 5, and now I will point to the run script for RWC. So with that, the SMKRUNs will load the content of the RWC run script directly into the interface, and on the left panels it will show the content of the directory that contains the run script along with all the run script in that same directory. Now again, in the source tab is where we are viewing the RWC run scripts. For now, let's just start running the scripts first, and then we will go back to analyze the content a different setting in this RWC run script. So let me start by just hitting the script button on the top right here and let it process emissions. Now as the run ready start running, we navigate to the input file, so we see each of the smoke core program will populate in the sequence that they being executed. So we see here smoke event was run first to import raw emissions from the EMP, and then SpecMat was executed to speciate from inventory into the model species of chemicals species. Then CritMat was follow up, which is the program to aggregate emissions from county level to motor grid cells level. Then we follow, and that is some smoke report was calling to create some report 5. Then temporals was run after smoke report to generate temporal allocations, which is to go from annual emissions into the hourly emissions in smoke output. And follow with that, into smoke merge. This is the main program that merging all of the intermediate output 5 generate from previous smoke core program to generate smoke output in the ready format that photochemical model like CMAC can use. So now if we navigate to the output 5, this is where we see in all of the intermediate outputs generated by each of the smoke core programs, smoke invents, SpecMat, GridMat, and smoke report. So several reports we generate for the RWCs throughout the processing. We will come back to this in the QA step that we will discuss later. And then smoke merge, like I mentioned, is where merge all the intermediate output 5 from previous smoke core program to generate smoke output 5 that CMAC can use. All right. So like when the Sun script was finished, let's go back. Now we will go through the content of Sun script and dive in a little bit on the different setting in the Sun script. So you see here the top part of the Sun script is where we define what sector or we're being processed in this case. This is RWC, and follow that either command shows directory definitions. Now this is a very important part because this is where SMKRUN will use to analyze for other environmental setting in directories definitions, and with that it will combine the value of those settings with others setting in the run script to give us something look like the extended path. So for example, it will look into the directory definition to analyze the setting for ge_dat and then stitching that with the remaining setting of the surrogate deck in this case, for example, and provide the ultimate file path for the surrogate deck. And then it will initialize other functions like checking for the valid path of those setting and provide a OK green check if it's confirmed the file actually exists on the local system. Okay, since we stay with this, so let's also stay this tab. So you will see there is several setting in the Sun script that present here. And again, with SMKRUN, we can look up for the definitions of each variable in the Sun script. For example, what is the definition for TRISDAC? The first part is this shows what program using TRISDAC variable. This is GridMat, which is the gridding matrix. And also another program is MatForMove when we process on-row emissions, for example. Definition for TRISDAC is provided here, which is essentially the abstract or excerpt from Smoke's user guide. And so it provides some reference into a figure 4.4 or table 6.37, which you can look up in Smoke user guide to gain more information. AGREF, for example, what is AGREF? This is gridding cross-reference files using by GridMat program. Now, the way that the EMP run script is, it have a lot of setting upfront, and not all of them relevant to the sector that we've been processed for. For example, in this case, we're processing for RWC, but we do see some other setting like empty draft. Those are temporal reference for mobile source, which is not being used for processing RWC, even though they are specified in the same run script. So if you go back to the source tab here, there is some command lines say those setting is for all sectors, meaning it's not just for applicable for RWC only, but it's applicable for other sector like point source or mobile source or biogenic source and so on. So for example, we also see some PEV config. Those are relevant for point source, which is not relevant for RWC in this case. But it gives you the concept how the EMP run script is organized. And then under that, then we navigate down toward the later part of the section. Then they will say some input is specific to this sector or job. In this case, it's specific for RWC. Now, what we see in here is the multiple like GSREF, TMP underscore A, B, C, E, and F. What they are, what they actually are. So this is where we can go back to the variable tab and navigate to where the GSREF temp was defined, for example, and then right click on that and look up for definitions for GRF temp underscore A. So what you see in here is they are not smoke core program that's using this GSREF temp underscore A. What's listing here is what we call the EMF run script, or the script using by the EPA EMP platform to process emissions. And each of those EMP script will call subsequent helper script and then initiate smoke core program to process emissions for RWC. So in other words, this GSREF temp underscore A, you wouldn't find the definitions from the smoke user guide because they not belong into smoke core program, but they are using in the EMP run script structure. And this is a list of the EMP run script that use that GSREF underscore A or B or C as we saw in this run script. Now, if we navigate to the run log and pull all the way to the beginning of the run log, here we can see there's a combine data.chh was called to concatenate all the GSPro temp underscore A, B, C, D, E, and so on, and concatenate those files into a single GSPro that SpecMat will read into do speciations. Similarly, the combine data.chh also will execute to concatenate GSREF temp underscore ABC and so on to create a single GSREF file that's SmokMat used for speciation. Indeed, if now we transition into the input file tab and look under SpecMat, this lists all the input file for SpecMat program that was used by SpecMat. And we can see here that a single just one GSPro file. This is the combined GSPro from that combined data.chh. Similarly, there is a combined GSREF that was combined from across different GSREF temp underscore ABC and so on. So there is those two combined GSPro and GSREF that actually read in by SpecMat to do the speciations and processing. So that gives us an idea on how those GSREF, GSPro multiple setting was combined as the actual emissions processing was happening. There is also setting like ATDREF, for example, which is the temporal cross-reference files. Now, if you notice that there is another AT draft was defined in the earlier sections of the SMKRUN script. The way that C cell or T cell script was operated is that any later setting of the same variable will override its earlier setting, meaning at this point the AT-rep will be override with this particular setting with point to this particular file and override the setting in earlier AT-rep. Similarly, if you go to later part of the SMKRUN script, we see there is a setting for ELP type and M type in this one sections, but later there is another ELP type and M type defined close to the end of the SMKRUN script. So this is actually the value will be used in the emissions processing and override the earlier definition of ELP type and M type. Now, if you wonder what ELP type and M type are, as you can guess, we can go back to the variable tab, navigate down to where they are defined in the SMKRUN script, and right click on the variables and look up for definition. Again, what you're showing here is that ELP type and M types is not actually used by smoke core program, but it is used by various EMF SMKRUN scripts that will specify the frequency and how to, for example, the ELP type determine how smoke will use reprocess emission or temporal intermediate file for what we call representative days. We can talk more about that in a little bit. And ELP type is determined for a temporal, how temporal program will process for emissions for representative days. Then if you look up for the M type, again, M type is not used by smoke core program, but for EMP's run script. And M type in this case will determine how smoke merge will merge those intermediate output files for representative days and merge them together to make smoke model ready output file. Now there are different settings for ELP type and M type, and they could be as listed here: every day, week, MWDSS, or all. And we can talk about this setting by looking to the merge date setting, merge date file. So you can see here, currently the smoke's merge date file points to a file for December 2021, even though we are processing RWC emissions for January 2022. This setting is okay because smoke's transcript just use these merge date files as the pointers to locate the directories where it will look for the corresponding merge date file for January 2022. Indeed, if you view the content of this file, it does show the setting for December 2022. Now, in order to see the content of merge date file for January 2022, again, navigate to the sort tab and hit edit script, and then locate where merge date file is set. Right at these locations, see if I go to change that to January 2022. Now, there is several options for me to choose to save my edit. One of them is just finish editing. This will save my edit at a temporary, which then I can execute a run script in a temporary run script, or I can save it to file to save my edit permanently to the raw smoke run script. So I don't want to save my edits at permanently yet, so in this case I just hit finish editing. Now if I navigate to the variable tab, this merge date file now points to January 2022. Now, if we view the content of this file, there are several columns in this merge day 5. The date column specifies each calendar days in January 2022, and there is several settings to map representative days to each day in January. There is setting for average days, where only one representative days is specified for entire month. There is Monday, weekdays, and Saturday and Sunday, or MWDSS, where there are 4 days specified as the representative days for January. And we have weeks. As you can guess, there are 7 days to represent each day in the week, and they serve as their representative days for January. And then under old, then each day will be processed emission separately for each of the day in the month. There is underscore n and underscore y, and if it's specified with underscore y, meaning there is holidays, it also consider, because in January we have one holiday, which is January 1st, and when we go from local to UTC, a few days in January 1st does spill into a couple hours in January 2nd. So that is the reason why we have 2 days represent for holidays in January, and they are mapped into corresponding days in the month of January. So, whereas in April date underscore no, there are only 1 days as a representative days for entire month of January. In the setting for April date underscore y, there is now 3 days, 2 for holidays and 1 for the remaining days of the month. Now, if you wonder where holidays is specified, that is set under this holidays variables here. So if we view the content of this, and as we scroll down to the bottom of the file, this is how holidays in holidays in 2022 is specified. So you can see here there is January 1st specified as a holidays or New Year's Day in 2022. There is no holidays in February or March, as an example. Continue our discussions about setting up L type and M type. In this case, because both of them are specified to all, which means that each day in January 2022 will be processed emissions separately. Indeed, if you now transition into the output file tab and look under smoke merge, there are indeed 31 output file generate for RWC in January 2022. Now, if you wonder what it will look like if we have different settings for L type and M type. So let's assume now instead of processing emissions for January, now we want to process emissions for February. So we change my run month to February, and then scroll down to the bottom of this run script and change that to, instead of every day in February, now let's say I want to process that just only for 4 days and using the month, weekdays, Saturday and Sunday, and do the same for M type. Okay. So now here, finish editing. Go back to the variable tab. Let's already update L type, M type for MWDSS, and the run months now should be February. So now you want to check, let's merge day 5, it still point to January 2022, even though we're processing for February now. And like as I mentioned earlier, this is okay because SMKRUN script just using this 5 as the pointer to locate the directory where it will look for the correct merge day 5 for the month that's being processed in Emission 4. So with that setting, now we can hit the run script. You ask me to confirm if we will start doing the processing. So as indicated earlier, you can navigate to input 5 to see what programs being run, what input files being utilized. So we being Thunder temporal. In the smoke merged. Okay, so the run script is complete with SS code 0, meaning it's run successfully. So now we transition into the output 5 and look under smoke merged. So right now, instead of 28 files for February 2022, we only now have 4 files or 4 days of process for January 2022's, because as we apply the Monday, weekdays, Saturday and Sunday, which means we're using 4 representative days for the month of February. This is how many days being processed for February 2022. Okay, so let's do a little experiment here. Let's say I want to make some modifications to the setting of out type and M type. Now I still keep out types at Monday, weekdays, Saturday and Sunday, but now change setting up M type to week. Okay. Now the quick reminder here is that out type will control smoke temporal programs in how it's processed, temporal allocations during the processing step. With the MWDSS, it will only processing emissions for 4 representative days. In the other hand, the M type will control how smoke merge will merge or the temporal or intermediate output file generated by various programs, including smoke event, SpecMat, GridMat, and temporals is one of them, and merge together to generate smoke output file. And with the setting up to week, the smoke merge expect there should be 7 representative days already processed for it to merge 5 together. So in other words, I intentionally introduce some mistake and with the clear intentions to cause some issues during the smoke processing. So with that setting, just save it temporarily and do some run to see what would be the outcome. So confirm and run that. Okay, now this processing was stopped with some error reported. Now it exists with code 1, which means some error was detected during the multi-processing step. So now it's point to the smoke merge, some error detected in the log file of the smoke merged. So then we navigate to the log analysis. I hit analyze current log. So this tab kind of condense the run logs to like pops out any warning or error it detect in the run log. So again, there's an error pointing to this particular, which is the log file from the SmokeMerge program. So we can click on this message and we ask whether we want to view the content of log file. To do we did, and then navigate to the bottom of these log files where they say it couldn't find some intermediate output for Julian date 40 in 2022, which corresponding to let me see, it could be, yeah, it should be February 9. So in a way, it essentially, it said it couldn't find the intermediate output 5 for February 9 in 2022, which should be generated by tempo program. But because we intentionally setting the L type to Monday, weekdays, Saturday and Sunday, and the M type is set to a different frequency, different from M type. So that explains why the smoke merge couldn't find the file that we were looking for to do the merging step. So indeed, now if we edit the script, just view the content of merge day 5 for February 2022, finish editing, go back to the variable tab, now check the content of the merge day 5 for February 2022. Remember the L types was setting to MWDSS, so you can see here there are only 4 days and none of that point to February 9. But under the week setting, there is SmokeMerge will expect February 9th will process by tempo programs for it to do the merging. But because it couldn't find shut 5, it caused error on the SmokeRun stop with the error that's reported by SmokeMerge. Now you can also see that for February, the setting between with and without holiday considerations is identical, because like we saw earlier in the holiday days, at the holidays 5, there was no holidays specified for February. So what I just demonstrate here is how we can utilize the log analysis tab to analyze any warning or error message that may happen or occur during the run log, and doing necessary debugging if needed to correct any issue or mistake that may happen throughout the emissions processing step. Okay, so with all the setting and the intentional bug that we introduced to the run script, what if we want to recover our original and working run script? So we can easily recover that by just hitting the reset script button here. So it's asked me to confirm that discard all the edits that I make to the file and reload it from the disk. See if I hit yes, now everything should be reset to original state. So in this case, runs month is reset to January. The merge day 5 again should be point to December 2021. So everything reset to original setting as it was from the run script without any edits that we introduced so far to the run script. Okay, so with the run script reset, I now can hit the run script again just to reprocess RWC emissions for the month of January 2022. You're gonna leave it run a little bit until it's complete. So we see in here, the output file from smoke mirrors is gradually to populate for each day in January 2022 until all 31 output files was processed. So this is where we transition into how to visualize or plot the output file from smoke after the emissions was processed. So even though output file is still being generated, but for example, let's say I want to visualize output file for January 1st and January 1st. And to do so, this is another interesting finding. So you notice here, look like the run log is finished, but it's still some error was reported from this run log. And now if we look back to the log analysis, just analyze again, and it's not pointing to any particular log file which detect the error, but it's some error message which pick up somewhere and it suggests to review this log analyzers for the error that it picked up along the way. So we click on this message and open that rep logs. Okay. So this is the content of log analysis programs. Basically the program that's combing through all the log file, generate across different programs and screen for any warning or error message that was indicated in those log files. And as we go through this list, there is some error abort was detected in the smoke log file for February 9. Now, what we just did is processing emission for January, but it still picked up the error that what happened in the smoke merged log file for February 9, which is a step where we intentionally introduce some mismatch between L type and M type. So this demonstrates that even though our processing emissions for January was successful with no errors associated with January's, the log analyzer programs may still pick up some errors that happen for some log files at the as leftover from our previous exercise where we introduce intentionally introduce bug or missed or error into the processing. So in other words, it's important to analyze the log analysis, the report files generated by log analysis, to screening for any warning or error that should be that we should pay attention to make corresponding corrections if needed. In this case, it's not needed because we know that the errors in the smoke merge log files was from our intentional international introductions of issues into the processing. So it could be totally okay to ignore this error message in this situation. Now, the processing for January already complete. So going back to discussions of visualize smoke output 5, to do so, we can right click on smoke output and hit plot emissions. And what happened in the background is SMKRUN call a companion tool called smoke plot that will handle the visualizations of smoke outputs as well as the input 5. So in this case, this is a GUI interface of smoke plot that is already loaded with the credit emissions for RWC from January 1st. Now it provides the interface, the box that we can select the pollutants to do the visualization. So let's say I'm hit methane in this case and do the plot. So this is how the credit by credit cells emission look like for methane over the output 5, in this case for the 12 lit source domain with 25 by 25 grid cells. We can hover the mouse over each grid cells and get the live reporting of values under the grid cell. You look at the top right corners with the lat long grid rows and column number as well as the emission values associated with each grid cell. Now because this is a NetCDF5 with time dimensions, we can looping through each stem step in the 5 to visualize the values. If we click on any grid cells in this plot, that will give us the time series of emissions values across all time steps in the 5. And these provide a statistic of minimum values, mean or average, maximum or sum total across the view window here or domain in this case. But as we zoom in any particular area using the mouse to draw a rectangle, the statistic also update in relative to the viewing window that we are looking at. And of course, we can always select a different pollutant to do the visualizations, or using different scale. Okay, so that is how the visualizations of output 5 be handled in SMKRUN and its companion tool SmokePlot. Like I said earlier, we can also visualize another type of output from emissions processing, which is a smoke report. So it depends on how the report file was configured in the run script. We can have different type of report generated throughout the emissions processing. In this case, these are all different level of reporting files generated by smoke report program. Some of them we can kind of infer the content of the report by the file name. For example, here is the emission report by county level. Another report breaking down by the speciation profile applied to different counties. And then we have another report where it's reported by county level as well as SCC, which stands for the source classification code. So each of them have different kind of reporting type and level of information that they provide. Let's say now we want to visualize or look into the content of emissions by county and by SCC. So we can do that by two ways. One is right click and then view content. Just view the content of report files as the text format. And as we can see here, we have emissions report by various pollutants in tons per year and broken down or classified by regions or the county code, state, and by SCC. So this is the report file in text format. And we can also do the visualizations and plot the smoke report file using the smoke plot tools. So a familiar GUI interface again. In this case, it's loading with the report file that we select. Now, with this file, because it's a county level, the plot types will be, so under the plot type, there is option to plot by grid or by grid cells or by counties. But because the report file in this case only have emissions classified by county level, so the appropriate would be the counties, or let smoke plot automatically determine the correct plot type to apply in this case. And let's say we select any pollutants, again go with methane and do the generate plots. So we can see here, this is how emission look like at the county level. This represents all the county within the domain, modern domain that we process emissions for. Similar to the NetCDF that we saw earlier, the live static values associated with each grid cell as we move the mouse over that. And because this is just a static text format, there is no time dimension associated with this file. That's why there is no like looping through the stamp step as we had earlier with the NetCDF output file. But certainly we can still do the zoom in and zoom out with the update statistic in relative to the viewing window. Then there is view table that you can look into the content of the report file. There is several level of summarized data that we can make. So summarized by state, by counties, or by state. So we summarize by all the states associated with the county, or by SCC. And then the option to export the content of this data table into a CSV that can be used in subsequent post processing. Now we can reset to the original view window. So smoke plot, there's a lot more options that we can do with smoke plot, which I'm not going to cover in this demonstration, but you're welcome to go into the GitHub repo smoke plot, and there is more documentation of how smoke plot can be used. So let's look at another smoke report type. So this is another report that organize emission data by grid cell level as well as the county. So we right click to view the content of this smoke report file. As you can see here, we have emissions across multiple pollutants and classified by X cells, which is the column number, and Y cell is a row number, and as well as by the county. So again, similar to the earlier smoke report file, we can do plot emission to visualize the emissions in map format. Okay, and select methane and generate plot. Now, I will start in content because in this report file, the emissions is organized or classified by row and column number, or in other words, they organized by grid cells. That is the reason why now we can visualize this emission data in by grid cells format. Do lot scale. We use a different scale, or we can specify the custom by color bins or value bins to plot the emission data. Now, because this report file also organize emissions by county level, so here that's where we have another options to plot by county. But now instead of by grid cells as earlier, now we have emissions plots or organized by county level. Now I would highlight thing that for plot by grid, there are two requirements. One is the report file cells must have emission data organized by grid cells, and then the smoke plot needs also know the grid stack or the grid informations of the domain the data is valid for. Based on this grid stack 5 and associated with the grid IDs, it will build kind of underlying shapefile of the domain where it's then map the emission value into the domain and comes up with emission plot by grid cells in this case. But that information is already preloaded into smoke plot by default. But for your application for a different domain, you might need to load a different grid stack file and select a different grid IDs that is valid for the emission data that was processed for. Okay, I think this is a good time that we transition to a topic of QA QC. So I already mentioned about smoke report, the kind of report that generates throughout different emissions processing step. And for QA QC purpose, what we want to do, for example, is to make sure that the output from smoke or from emission processing be consistent with the input file. And the input file is indicated under the input file tab, where it indicates all the input file associated with its smoke core program. Now let's say, for example, we want to examine the contents of the input emissions for RWC. So as indicated here, there is two files irrelevant to this. There is a list 5, but in this case, if we view the contents, there's only a single raw emissions 5 for RWCs as specified for emissions processing, and because of that, the list file only have one file, which essentially is this particular one. So the view content. This is the FF10 known point format where emissions is indicated by each rows and organized by the country code, FIP codes, and SCC. The typical FF10 known point format. So in addition to viewing the content of the file by as in the text file format like we did earlier, we can also have options to visualize using the emission data using smoke plot tools. Now, smoke plot can handle individual emissions file, or it can also handle the list file, which may contain more than one emissions file. So in this case, just right click on the list file and do the plot emissions. So the broad emission file usually is at the county level, so that way we can leave it just as plot type autos and leave it the pollutants to methane in this case and generate plot. So this is how emission look like in the raw emission input file. Let's say I want to compare this to smoke report file, and I want to make sure that what generated by smoke report, meaning the emissions import to smoke, being processing to different program, the output of that should be identical to the input raw emission input file. And to do that, I go back to the SMKRUN interface, go to the output file format tab, and locate any appropriate or smoke report file that I can use for the comparisons. Let's say I want to go to emission report by counties or by SCC, and now I do plot emissions. So now to give me another smoke plot interface where it's loading the smoke report file, and let's go select the same methane pollutants and do the generate plot. Okay, so now we have two plots. One on the right is from smoke report, and the ones on the left is from the raw emission input file. So let's just minimize a bit so we can see both of them on one screen. All right, so here we have side-by-side comparisons of methane emissions at county level from raw emissions input file on the left and methane emissions at county level from smoke report file on the right. Looking at the statistic associated with each plot, we can see there's some discrepancies between the emissions value between the raw emission input file on the left versus on the right. And the reasons for this is how methane emissions was processed through smoke. So methane emission from raw emission input file in this case was not being considered in the smoke processing. Essentially it would drop it. Instead, methanes were actually calculated from VOC by using VOC speciations profile. In fact, now if you look under the drop box for pollutants from raw emission input files, there are only about 13 pollutants associated with the emission input, whereas if we check under the drop box for the pollutant drop box from smoke report file, there are a lot more pollutants than the raw emissions input. Many of these species, for example, ethane, ethene, formaldehyde, and so on, are organic compounds that were calculated from VOC by using VOC speciations profiles. Similarly, there are multiple aerosols of particulate species, for example, ammonia aerosols, nitrate aerosols, organic compounds aerosols, and so on. Well, that was calculated or speciated from PM 2.5 emissions by using PM 2.5 speciation profile. And that explains for the discrepancies between methane from raw emission input and methane as it was calculated from VOCs in the smoke report file. Now, if we look for another pollutant, carbon monoxide or CO, for example, so do the plot for the raw emission input file. Now, in the drop box for pollutants from smoke report file, we don't have the similar CO pollutants. Instead, we have what is called CO, which stands for inventory CO, and then another SCO, which stands for spatiated CO. And the way CO was handled in emissions processing, and was mapped in one-to-one manner, meaning all input or inventory CO will be converted into spatiated CO. So in fact, let's just try to plot ICO. So just keep those number in mind, and then we do the same thing for SCO in this case. We would see essentially identical statistics number, and these number are indeed agree with CO emissions from the raw emissions input file. So this confirms how CO was handled in emissions processing, and this also confirms that what we have in raw emission input files agree with what we have as an outcome from smoke processing or emissions processing steps. So certainly there are a lot more steps involved into the comprehensive QA/QC to make sure that everything in the output are what they're supposed to be. But what I just demonstrate is just an example how we can use tools like Smallplot to do quick QA/QC and verifications between input and output. So this concludes my demonstrations of using tools like SMKRUN and Smallplot to run the EMP's run script to process emissions in interactive way and do additional analysis. Certainly you can use the same approach or tools to process emissions for other sectors, for example on-road, non-road, or point source even. And so thank you for watching.